Hello, my name is Maggie Netterval, and these are my wonderful teammates, Brittany Lavelle and Elizabeth Gross. Together, we built Lack, which is a real-time messaging app that helps teams streamline their communication and prioritize which notifications they receive based on customizable settings. Lack was inspired by each of our experiences with group communication, both here at Grace Hopper, as well as at the startups we worked at previously. We're constantly communicating, and the combination of long email threads and other messaging apps like Slack can lead to an accumulation of communication avenues that don't have a clearly defined purpose or end date. The notifications will just lead to a barrage of noise in your life, and it can be very difficult to extract what you need. Elizabeth will tell you more.
With Lack, users create communication channels called rooms with specified objectives and expiration dates. We deployed a Heroku web worker, which leverages Node cron jobs to delete the rooms on the expiration date specified. The main feature that sets Lack apart from other chat applications is the user settings. To manage notifications, users can create lists of buzzwords and VIPs for Lack to monitor. Like chat messages themselves, these lists are accessed via Firebase arrays using AngularFire's three-way data binding among the DOM, Firebase, and Angular. Any changes to the Firebase array triggers a change in a CSS background color class of the corresponding room in the sidebar.
In our tech stack, we use Firebase as our backend and database, and AngularFire as our intermediary between Firebase and Angular. On the front end, we use Angular and Angular Material. To maintain security throughout our application and to simplify the signing up process, we utilized Firebase's authentication service through Google, and we deployed our application using Firebase's hosting services. As we mentioned earlier, we use a separate Node web worker to incorporate email and cron job functionalities. So when users are invited to join a team, they receive an email, and room administrators can also email room members with notes from that room after it is closed. One challenge we encountered was the modeling of our data in Firebase. In Firebase, data is stored as a JSON tree in a NoSQL format, as opposed to the relational database structures we studied at Grace Hopper. In relational databases, information is stored in tables and associations are created through join tables. However, Firebase creates associations through nesting. When Firebase grabs data from the database, it also grabs all of its child nodes, which can result in the retrieval of too much information. So knowing something like the team name a user is a part of is important for something like the welcome page for that user. However, knowing information like the date in which the team was created or the team administrator is not. So optimizing our code requires flattening out the data in our database structure. Our application utilizes numerous associations between teams, rooms, users, messages, and settings at various points throughout the chat workflow. And we were able to maintain a fairly flat database structure, and it was a really good learning experience.
As Brittany said, we really enjoyed diving into several new technologies together while building this, and we're super excited about implementing additional functionality in the future. But in the meantime, you can check us out at lack.tech. Thanks for your time.